Unit 6, Lesson 4, Graphing Reciprocal and Rational Functions. Some of the key characteristics we're going to take a look at here are the vertical asymptote. So an asymptote is a line that our function does not cross. So it will continue to approach that line, but will never touch it. And that is pulled from our denominator. So in general, it's x minus h, and you set that equal to 0. H would be a number, and then you solve. So like if we add h to both sides, x equals h. And then our horizontal asymptote is pulled from something a little bit different. I'll take a look at it when I work through some of the problems and help clarify that. The vertical asymptote is a dashed line, and that indicates a value of x that the graph can never touch. And then, like, you have these fill-ins. I just kind of want to explain how it works. You can get these filled in. So the steps, we're going to find the vertical asymptote by setting the denominator equal to 0. We're also going to find the horizontal or slant asymptote. We'll talk about how you find each of those in context of the problem is probably the easiest way to see it. Then we're going to find the x-intercepts and y-intercepts. And remember to find an intercept. To find the x-intercept, we make y equal to 0, and then we solve. To find the x-intercepts, x-intercepts, y equals 0. To find the y-intercept, x equals 0. So we're going to make each one 0 and then solve. I'll show you what that looks like. And then we may need to find other points so that we have 2 on each side. You'll see what that looks like, and then we'll sketch it, okay? Here's some more information about just kind of understanding the horizontal asymptotes. I'll talk about it as I work through each of these examples. That way I'm not wasting your time talking about it and then re-explaining it here. So for our first example, vertical asymptote. That comes from taking our denominator and setting it equal to 0. So the work for that would be x minus 2 equals 0. We add 2 to both sides, and our vertical asymptote is at x equals 2. So what that means, I'm going to put that on the graph, is through 2, there is this like vertical line that our function will not cross, okay? And then horizontal or slant asymptote, the way that we do that is we're going to look at our expression here, at our function, and we're going to look at our x values. So I have a denominator, and the degree of the x right here is 1. And I do not have a degree on top. So my denominator is bigger than my numerator, which tells us we have a horizontal asymptote. That's going to be a horizontal line going through our graph. And for this, it's going to be at y equals 0. I'll show you what some of the other ones look like when we do some of the other problems. Okay? And so there's really no work to find that. That's just kind of known, okay? So y equals 0 is our, and what that looks like on the graph is there's this line here that our functions won't cross, okay? So let's talk about this thing that says other points. If we have x and y values where we know our vertical asymptote is 2, okay, we're going to be able to do a couple things. We can count down 1 and 0, and we can go 3 and 4. There may be some other points, though, that we could use based on the work that we have to do for the x and y intercept. So for our y-intercept, right, when we make x 0 and solve, if I have 1 over 0 minus 2 and I solve, that is negative 1 over 2. So when x is 0, y is negative 1 over 2. Or negative 0.5, right? For my x-intercepts, that comes from setting our the x values in our numerator equal to 0, but we don't have any work for our numerator, and that's based here. There are no x-intercepts for these ones. So when y equals 0 on our horizontal asymptote, there are none. There are no x-intercepts. Okay, so I'm going to use this space over here to work out 1, 3, and 4, and then I'm going to write their corresponding values down here, and we're going to plot them, and that's all we'll need to do to graph this. So 1 over x minus 2, and I'm going to do some like iPad work just so I don't have to write a million things down. But if I plug in 1 there, that's going to give me 1 over negative 1, and that's really just negative 1. So when I plugged in 1, I got out negative 1. When I plug in 3, that's going to give me 1 over positive 1, which is just 1. So when I plugged in 3, I got out 1. And then when I plug in 4, it's my other value, I get 1 over 4 minus 2, which is 2. So I get 1/2, or positive 0.5. And there's not really, like, this one looks like there's a pattern to the numbers that we got, but that's just how this worked out. You kind of just have to do each one individually. Okay, so these are x and y points that I'm going to put on the graph, and I'll show you what that looks like. I'll use purple here. So at 0, negative 1/2, so 0 and negative 1/2 would be here. I have a point. And then at 1, negative 1, I have a point. And what happens is I get like this curved graph that follows my asymptotes. And I'm going to get another one over on this side. So they should be opposite of each other. So I'm going to get another one over here on this side. And at 3, positive 1, so 3, positive 1, and at 4, positive 1/2, which would be there. And I get this like graph that follows these. It never crosses that dotted line, the asymptote. It's always just going to get closer and closer. So because we had an asymptote on the x-axis, that's why we won't have like x-intercepts, because we can't have points on that line. That's why we had none here. Okay, so I'm going to go through another example. Number 2 here. For my vertical asymptote, I'm taking x plus 1 and setting it equal to 0. That comes from the bottom. So that means that x equals negative 1. So that tells us that at x equals negative 1, there's this dashed line that our graph is not going to cross. Okay, so to figure out our horizontal or slant, we are going to take the degree of our biggest degree of our x values here. So that would be 1 over 1, because it's negative 2x to the first on top and x to the first on the bottom. When these match, okay, so on the last one they didn't match, my bottom was bigger than my top, and that gave me y equals 0. But for this one, when these degrees match, we use the leading coefficient. So the leading coefficient here would be negative 2. So this is horizontal because they match. So if it's 0 on top, or like if the bottom's bigger than the top, or if they're the same, it's horizontal. And then the work to find it, we're going to take our leading coefficient, so negative 2 over our leading coefficient. So that's negative 2 over 1, and evaluate that, and that's going to give us negative 2. And so the way that we write that as a line is y equals negative 2. Essentially what that does is it shifts our horizontal asymptote down 2. For our x-intercept happens when we make y 0 or f of x. So if we had 0 equals negative 2x plus 1 over x plus 1, we could get rid of this x plus 1 by adding it to both sides, or by multiplying it to both sides. And what you're going to notice happens is this cancels out with this 0. It still just makes 0. And these cancel out, so we just have negative 2x plus 1 that we need to solve for. So when y was 0, x is negative 1/2. So if I do this other points thing, our vertical asymptote was at negative 1. And 0 would, in relation to negative 1, would be here. So, So 1/2, I should say. So if x is 1/2, 1/2 is larger than negative 1, and y is 0. If you notice, like, the shortcut for this, all of this work, is that we really just take the numerator and set it equal to 0. That's what we have here, and then solve, and that gives us our x-intercept. For our y-intercept, we're going to make x 0. So y equals negative 2 times 0 plus 1 over 0 plus 1. And these essentially just kind of cancel out, so it's 1 over 1. So when x was 0, and 0 is going to be on this side of 1. So 0, we got 1 over 1. I have 2 points on this side, which is great, but I'm missing 2 points on this other side. So I'm going to pick 2 numbers smaller. I'm just going to go in order. So I'm going to say negative 2 and negative 3. So if I plug those in to my function, negative 2, if I put a negative 2 in here, that's going to make positive 4 plus 1, which is 5, over negative 1, which makes negative 5. Okay, and if I run that back, but this time I use negative 3. Let's see, that will make 6 plus 1, which is 7, over negative 2. So that should be negative 7 over 2, or as a decimal, 7 divided by 2, which gives us 3.5, negative 3.5. So I'm going to count 3.5 there. So if I put these points on the graph, let's see if I can just use a highlighter here, 3 and negative 3.5. So if I go negative 3, negative 3.5, which, that's way too big. Let me fix that. Yeah, it would be about there, right? 3 and 3.5. And then negative 2, negative 5. So if I go left 2, down 5, 1, 2, 3, 4, 5, that would be about there. And that's going to make this shape. You're going to see it kind of follows the curve of our asymptotes. And then for my other side, I suppose I could use like blue, right? Oops. Except that's a little too small. For 1/2 and 0, so if I go 1/2 and 0, that's just right there. And then 0 and 1 would be here, and you notice that this one, so it was like there and there, is going to follow our asymptotes this way, like that. Oops. So my red and my blue end up being my answer. Okay, I'm just going to keep working through these examples, just so that you have a couple that are actually worked through and can reference. So again, to find our vertical asymptote, we're going to set our denominator equal to 0 and solve. 2x equals negative 3. We divide 2 to both sides. X equals negative 3 over 2. Okay, to figure out if this is horizontal or slant, we'll talk about slant in a moment, but we're going to take the degrees, so 1 over 1, those are equal to each other, so that tells us it's horizontal, and we're going to need to we're going to take our coefficients, so 1 over 2, that came from 1x and 2x. We're going to take those, and that actually tells us how much we are shifting. So our horizontal asymptote shifts up 1/2. So I'm going to put a line through 1/2. Just like that, dashed line through about 1/2. Our vertical asymptote is at -3/2, which would be -1 1/2. So -1 1/2 would be about here. It's kind of a tricky example. So we should expect we'll have like matching U-shapes maybe in here, or they're going to end up here across from each other, but that's what we should end up looking like here. Okay? For our x-intercept, remember we make y 0. So when we make y 0 and solve, the denominator pretty much goes away. So 0 equals x. So when y was 0, x is 0. And that's also true then for our y-intercept. If y is 0, then x is 0. So we could go through and do the work for our y-intercept if you want, which is making x 0. And we would get 0 over 2 times 0 plus 3. And you'll see that makes 0 as well. Okay? So let's see what points we have, x and y. And our vertical asymptote was at -1.5, right? 3/2 is 1.5. 0 is larger than that, so 0, 0 goes there. I'm probably going to want like maybe a 1 and maybe a -2 and a -3. Okay, so I'm just going to plug those into my function and then see what I get. So I'll use this space over here. I've got x over 2x plus 3. So let's see what happens when I plug in a -3. That's going to make -3 over, that would make -6 plus 3, which is also -3, which would be 1. And because I'm on the iPad and can just erase, I'm just going to erase and leave that kind of template there. If I put a -2 in here, let's see, that would make -2 on top. And then these multiplied would make -4 plus 3, which would be -1. So that's going to make a +2 when we do that. Okay, and then the last one I'm going to do is this 1. So let's see. If I plug a 1 in, 2 times 1 is 2, plus 3 is 5. So 1 over 1/5. Or I mean 1 over 5, so 1/5. 1/5 as a decimal is 0.2. So it's like not quite all the way to 1, right? So when I go to graph these, let's see. -3, 1. 1, 2, 3, and 1. And then -2, 2 would be here. And look at what's happening. This is exactly what we want. These should be inside together. If I'm crossing over that line, I did some math wrong, maybe a sign or something. Okay, 0, 0 is here. And 1 and then like 0.2. So if I go 1 and then 0.2, it's like closer here. And look what's happening. Okay, so that would go there and that would do like that thing. Okay, so I get those across from each other. So those are with horizontal asymptotes. There's a practice problem here. I'm going to skip over and go down to example 4. These ones we're going to have vertical asymptotes. So we're going to have slant asymptotes. The vertical work is still the same, so x minus 2 equals 0, which tells us x equals 2, which means at 2 I'm going to have a dashed line. And then to figure out horizontal or slanted, we're going to take our leading coefficient, or our largest degree, so 2 over 1. And in this one, our numerator is the bigger number. So it's going to be slant. So when the numerator is bigger, it's a slant. When our denominator is bigger or it's equal, it's like 2 over 2 or 1 over 1, it's horizontal. So let's see. To find, so this is pretty wild, but to find our slant asymptote, we're going to do synthetic division. So we're going to take x squared, which is 1x squared, plus 0x minus 1. And then we set up 2 comes from being the opposite down here, so 2. And then we bring down the 1. 2 times 1 is 2. So I'm going 2 times 1 is 2. And then I combine these. 0 plus 2 is 2. And then 2 times 2 is 4. And then I combine these and I get 3. And then what happens right with the synthetic division is this is 1x plus 2 plus it's like 3 over x minus 2. But this is really what we're looking for. So this is the equation of our slant. Y equals 1x plus 2, which is in mx plus b form. So b tells us where to begin, so we begin at 2. M tells us how to move, up 1 over 1. And this is the equation of the slant. I'm going to estimate as best I can there, okay? Okay, we'll figure out our x-intercepts. Our x-intercepts, we take the top and essentially we set equal to 0. So x squared minus 1 equals 0. This is a difference of two squares. X plus 1, x minus 1 equals 0. And when we solve each of those, x equals positive 1 or negative 1. So on our x and y, our center is at 2, and at 1 and negative 1, we have zeros there. For our y-intercept, that's the one where we take our x values and we put zeros in for x. So when that happens, these essentially go away, and I get positive 1 over 2. So when y is 0, I get positive 1/2, which would fit in between. Oops, sorry, that was the wrong way. When x is 0, y is 1/2. So these go together. These go together. These go together. I'm going to use 3 and 4. I just need two numbers bigger. And I'm going to do a little bit of mental math here. So 3 squared is 9, minus 1 is 8, over 3 minus 2, which is 1. So I should get 8 here. And then 4 squared is 16, minus 1 is 15, over 4 minus 2, which is 2. 15 divided by 2 is like 7.5. And now I have points. So negative 1, 0. Let me use a different color. Let me use this orange color. Negative 1, 0. And 0, 1/2, which would be like up here, and 1, 0. And you'll notice what that does is it makes this little like U shape in here. It's going to follow your asymptotes. And then at 3, 8. So 1, 2, 3, 4, 5, 6, 7, 8 would be there. And 4, 7.5 would be halfway there. And those are going to make U shapes in here like that. So that's how we do a slant asymptote. Pretty wild. I'll do example 6. This will be the last example that I kind of knock out, but at least you have something to work with. Vertical asymptote is going to be x minus 1 equals 0, so x equals 1. So that's going to cut through here at 1. Okay. Horizontal or slant, remember we're going to look at, we have our largest exponent on top and our largest exponent on the bottom. The top is bigger, so that tells us it's a slant asymptote. And so we are going to use synthetic division. That's the coefficient, so 1x squared minus 1x minus 2. And then we use the opposite of what's in the bottom, so positive 1. And we're running it through this. So we're going to say 1 times 1 and get 1. Combine these, and then 1 times 0 gets us 0. And then -2. And really what we care about then is this is x, so it's 1x plus 0. So y equals 1x plus 0. And that's going to tell us the equation of our slant. So our slant starts at 0 and then counts up 1 over 1. Okay, x-intercept is when we set it equal to 0, and we really just do the numerator. So I have 0 equals x squared minus x minus 2. This is a factoring problem. So -2 and 1. I'm going to shortcut this, but it ends up being x minus 2, x plus 1 equals 0. And when we solve that, x equals 2 and x equals -1. So on our x and y, we have a vertical asymptote at 1. And then I have 2 and -1. And both of those have zeros because those are our x-intercepts, which is where y is 0. I'm also going to figure out when x is 0, which would fit about there. So that's for my y-intercept. When x is 0, I end up just getting -2 over -1. Because like all of these become 0. So -2 over -1, which is just 2. And this one's nice because I only have one more point to find. I'm going to find 3. So if I have 3 squared minus 3 minus 2 over 3 minus 1. Let's see what happens. This is 9 minus 5, which is 4 over 2, which is 2. Okay, and I'm going kind of quick, so I may have made mistakes, but we'll check as we go. I'm going to plot my points. So at -1, 0, I have a point, and at 0, 2, I have a point, and both of those points make sense with where they land in my asymptote. Okay, and then on my next one, I have 2, 0, 1, 2, 0 there, and 3, 2, 1, 2, 3, 1, 2, that's there. And both of those make sense within my asymptote. Okay, so a lot of work going on. Go back, rewatch these, watch the examples on these each time, but that's how we do graphing these crazy, what are they called? Rational, reciprocal and rational functions.